Hello students, I am Praveen Kumar from ABS Engineering College, Ghaziabad. In this video, we are going to discuss the working of a DC generator. The generator is a electrical machine which converts mechanical energy into electrical energy. The basic operating principle of generator is whenever a conductor is rotated in a uniform magnetic field, due to rotation of conductor, the flux linkages of conductor get changed and an EMF is induced in the conductor whose direction is given by Fleming's right hand rule. So the basic requirement for generator action is a presence of magnetic field, and in that magnetic field there should be a conductor which is moving with respect to magnetic field. So this movement basically is due to the mechanical input provided to the machine generator. So this mechanical movement gives rotation, and whenever a conductor rotates in a uniform magnetic field, an EMF is induced in it whose direction is given by Fleming's right hand rule. So just recall Fleming's right hand rule. This right hand rule gives the direction of induced EMF or induced current. This rule states that when we held the thumb, index finger, and middle finger of right hand mutually perpendicular to each other in such a way that thumb is pointed in the direction of motion of the conductor and index finger is directed in the direction of magnetic field, then the central finger gives the direction of induced current. For better understanding, let's discuss working of a single turn generator, in which we assume a single coil is being rotated in a uniform magnetic field. So this is the setup in which we are going to discuss the working of a generator. Here we are having a single coil in which two conductors are used. One conductor is conductor AB and other one is conductor C. And at the start of the observation, the conductor CD and AB, they are held like in this situation where the conductor CD is in front of us and conductor AB is not visible to us. As we can see that the coil is being rotated like this. So here the case 1, which is from 0 to 180 degree, in this situation, initially when we start our observation, the conductor CD is on the front and conductor AB on the backward direction like this. And here you can assume at one side is North Pole and at other side is the South. So in this situation, as we start rotation, the front face CD, due to the direction of rotation which is already marked here, due to direction of rotation in this direction, the front face CD is rotated and now it is in the influence of South Pole. And similarly, the back face of the coil, that is conductor AB, is now in the influence of North Pole. Here we can see that for the conductor CD, the motion is perpendicular to the plane of this screen and it is moving away from us. Whereas the conductor AB, for this conductor, motion is again perpendicular to the screen but this conductor AB is coming outward in our direction. So in this situation, if we apply Fleming's right hand rule, which states that the first finger should point in the direction of magnetic field, which is always from North Pole to South Pole, and thumb should be point in the direction of motion. So we can clearly see that conductor AB, which is in the influence of North Pole, it is carrying current in upward direction, whereas conductor CD, which is presently in the influence of South Pole, this is carrying current in downward direction. So in this particular case, this direction of current will continue as long as the rotation of conductor continues from 0 to 180 degree. After 180 degree, what happens? The conductor will again come in this situation where both the conductors, they are held in this position, and in this scenario The only difference is now the AB and CD phase have interchanged their positions. Now on the front side is the AB phase and on backward side is the CD phase. And if we further continue to rotate the conductor, what will happen? Now the AB phase will move towards the south pole, and the CD phase now will come into the influence of north pole. So in this situation again, the motion for both these conductors are going to change. Now the AB phase is moving away from us, and whereas the CD phase is moving towards us, and both for both the conductors we can say that their rotation is perpendicular to the display. Now in this scenario, if we apply again the Fleming's right hand rule, we find out the conductor CD, which is now in the influence of north pole, it is carrying current in upward direction, whereas the conductor AB is carrying current in downward direction. So we can clearly see from both the pictures that whenever a coil changes its field pole, the uh, direction of current in that particular coil is reversed. So we can see that when we rotate a coil in a uniform magnetic field, due to rotation of this coil, the EMF is developed in the coil, and that EMF is alternating in nature, as after 180-degree, the direction of induced EMF gets changed. So the question arises, then why this particular generator is known as DC generator? So this can be explained with the help of split ring and brush arrangements. Actually, this is just a elementary model. In practical machines, the same function is done with the help of commutator and brush assembly. Now here, again we are going to discuss both the cases. But here, what happens is both the coils, both the ends of the coils, say conductor AB as well as conductor CD. These ends are connected to the split ring portion F and E respectively. Here, this coil is being rotated, so conductor AB and CD, they are being rotated, and these both the ends, they are connected to split ring portion F and E. When the coil rotates, the split ring also rotate, and on the outer surface of this split ring, there are two stationary brushes. This is brush X and this one is brush Y. These brushes are stationary. So with this arrangement, we are able to maintain a unidirectional flow of current across the external load connected to the machine. Here we can clearly see that for rotation of 0 to 180-degree, as long as this conductor AB is in the influence of north pole, it is carrying current in upward direction, and as long as this conductor CD is in the influence of south pole, it is carrying current in downward direction. But as far as external circuit is concerned, the current is flowing from brush Y to brush X. Now, after a rotation of 180-degree, in which both the coil ends changes their field pole. Conductor AB is now in the influence of south pole, and conductor CD is in the influence of north pole. Now, in this picture, we can clearly see that as the coil ends has changes their field poles, in the meanwhile, due to the rotation, the split rings also change their brushes position. Here we can see that the split ring portion E, which is initially in contact with brush Y, now it is having contact with brush X. Similarly, split ring portion F, which is initially having contact with stationary brush X, now it is having contact with stationary brush Y. And in this scenario, still, as far as external circuit is concerned, the current will continue to flow from brush Y to brush X. So here, with the help of this split ring and brush arrangement, we are able to maintain unidirectional flow of current across the external circuit. So that's why this machine, this generator is known as DC generator, because in this across the external load, we are able to maintain a unidirectional flow of current. Now here, one thing we have to keep in mind, as we are dealing with single turn, that's why the current is not purely DC, it is a unidirectional pulsating current. But in a practical machine, this single armature conductor is replaced by the entire armature assembly having large number of coils. And a particular coil will remain in the contact of brushes for a very small duration in which current in that particular coil is at its maximum value. So by increasing number of coils, we can also maintain a constant magnitude of current. So in practical machines, these brushes and split rings, they are replaced with the help of commutator and brush, and we are able to maintain unidirectional flow of current. So this is working of a single turn generator. In practical machines, the commutator helps us in the following manner. First thing, this commutator acts as a mechanical rectifier and it converts the induced alternating current in armature conductors into the direct current across the connected load. Also, commutator collects the armature current and supplied it to the load through the help of stationary brushes. So this is the main function of commutator, especially in case of DC generators. So that's all for this video. I hope you have enjoyed watching this video. These are the references which are used for making this video. So thank you all for watching this video.